Hey everybody, in today's video we're going to be proving that lines are parallel. In the previous lesson we were told that if lines are parallel, then corresponding alternate interior and alternate exterior angles are congruent and consecutive angles are supplementary. But in this case we need to prove that the lines are parallel with these converses of the previous theorems. So the first one is the corresponding angles converse. So the corresponding angles converse says that if two lines are cut by a transversal so that the corresponding angles are congruent, then the lines are parallel. Okay, so we're just basically saying it backwards. We're not saying that the lines are parallel. We're saying if the corresponding angles are congruent, then the lines are parallel to each other. Okay, so an example from the picture up above. So we would say if, for example, let's pick a pair of corresponding angles. How about 1 and 5? So if angles 1 and 5 are corresponding, then line L parallel to line M. Okay, so that's what the corresponding angles converse tells us. Okay, so the same thing works with alternate interior angles. So if we can prove that the alternate interior angles are congruent when two lines are cut by a transversal, then the lines are parallel. So up in the picture above, let's pick a pair of alternate interior angles. So you should see two. There's two pairs. There's 4 and 6 are alternate interior, and then 3 and 5 are alternate interior. So what we can say is if, let's say, angle 4 and 5 are congruent, so if angles 4 and 6 are congruent, then line L is parallel to line M. Okay, and actually, let me go back to the previous one. This actually should be congruent. So we know that they're corresponding. We're trying to prove that they're congruent to each other. Okay, so the same thing goes for alternate interior. If we can prove that alternate interior angles are congruent to each other, then the lines are parallel. So in the picture above, we can find two pairs of alternate interior angles, for example, 1 and 7, and then 2 and 8. So if those alternate interior angles are congruent, then line L is parallel to line M. So let's say, how about if angles 1 and 7 are congruent, then line L is parallel to line M. And that's by the alternate exterior angles converse. All right, and then lastly, the same thing works with consecutive interior angles. If we can prove that if two lines are cut by a transversal so that the consecutive interior angles are supplementary, then the lines are parallel. So let's pick a pair of consecutive interior angles. So for example, 4 and 5 or 3 and 6. So if we can prove, so if angles, let's say 4 and 5 are supplementary, then line L is parallel to line M. Okay, so those are the converses of the theorem that we've done previously. So instead of figuring out what the measure of the angles are, we're saying if the angles are congruent or supplementary, then the lines are parallel. Okay, so now let's go down below. And on this example, we're going to be looking at this picture. As you can see, there's 4 different transversals. And what we're going to do is we're going to see with the given information, does that prove that the lines are parallel? So determine which lines, if any, are parallel, and then state the converse that we can use. So what if angle 2 and 4 are congruent to each other? Well, angle 2 and 4 are corresponding angles, and that would make line C parallel to line D. Line C and D would be parallel, and that would be, since they're corresponding angles, they'd be parallel because of the corresponding angle converse. Okay, the next one, what if angle 5 and 10 were congruent to each other? So 5 and 10, if we look at transversal C, 5 and 10 are alternate interior angles. So if those two alternate interior angles are congruent, that would make line A parallel to line B. And that would be by the alternate interior angles converse. All right, what if angle 6 plus angle 10 added to 180 degrees? So 6 and 10, that's between lines A and B. 6 and 10 look like they would be consecutive interior angles or same side interior angles. And if the consecutive interior angles add up to 180, or in other words, they're supplementary, that would make line A and B parallel. Okay, and that would be by the consecutive interior angles converse. All right, how about if angle 1 and 14 are congruent to each other? So 1 and 14, that's transversal C. So 1 is on the outside of line A, and 14 is on the outside of line B, and they're on different sides of the transversal, making them alternate exterior angles. So if those alternate exterior angles are congruent, like they're telling us here, then that would make line A and B parallel. And that would be by the alternate exterior angles converse. Okay, so we've done one of each. So if you want to pause the video and give the rest of them a try, feel free. But I'm just going to keep going through these. All right, so 14 and 15, that would be transversal B. 14 and 15 are between lines C and D. So if 14 and 15 add up to 180 degrees, that would mean that the consecutive interior angles are supplementary, making lines C and D parallel. And that would be by the consecutive interior angles converse. Okay, next one would be 11 and 16 are congruent. So let's find those two. So 11 and 16 are vertical angles. So if we go back up to the top, is there a vertical angles converse? Well, no, because vertical angles are within the same, or within just two lines intersecting, has nothing to do with transversals, has nothing to do with making lines parallel. So for this one, if 11 and 16 are congruent, well, 11 and 16 are vertical angles. They're always congruent to each other no matter what. So that wouldn't make anything parallel. So this would be none. And then there is no converse. I'm just going to put no answer NA. All right, how about if 14 and 15 are congruent? Or 4 and 15. So 4 and 15, looks like that's transversal D. 4 is on the outside of line A, B is on the outside, or 15 is on the outside of line B. They're on alternate sides of the transversal. That would make line A and B parallel. And that would be by the alternate exterior angles converse. All right, how about if 10 and 12 are congruent? So 10 and 12, that's transversal B. They're on the same side in the same position of the intersecting of the lines that B intersects. So that would make lines C and D parallel. The lines C and D would be parallel, and that's by the corresponding angles converse. How about if 9 and 13 are adding up to 180? So 9 and 13, what's their relationship? Well, that's a linear pair. Is that up above? Is there a linear pair converse? Well, no. If a linear pair is supplementary, they're always supplementary. That's never not going to happen actually. So 9 and 13 are a linear pair. They're always going to add up to 180. That doesn't make anything parallel because they're within the same intersection. So for letter I, that would be none. There'd be no answer for converse because none applies here. Or 2 and 7, if 2 and 7 are congruent. So that's transversal A. 2 and 7 are between lines C and D. They're on alternate sides of the transversal. So that would make lines C and D parallel by alternate interior angles. last one, 6 and 11. So if angles 6 and 11 are congruent to each other, let's see, 6 and 11, they're in two different groups, but there's no transversal connecting them to each other. So angle 6 and 11 don't have any relationship. So that one would be none. None of the above apply. So for this one, no lines are parallel. So then there's no converse that we can use. All right. So next we're going to take a look at a couple of proofs. So we did some proofs in the last chapter that we did. The proofs might have seemed a little bit difficult. These ones are definitely a little bit simpler, with a few less steps. So we're in this picture, number 2, we're given that angle 4 and 5 are supplementary. Okay, so if angle 4 and 5 are supplementary, we already kind of know, well, what does that mean? Well, if consecutive interior angles are supplementary, then line J and K are parallel. So that's exactly what we're trying to prove. But we're going to do it formally in a couple of steps. So why is angle 4 and angle 5 supplementary? Well, that's given to us. So our first reason is given. So then if angle 4 and 5 are supplementary, doesn't that mean that the angles add up to 180 degrees? So the next statement is angle 4 plus angle 5 equals 180 degrees. And that's the definition of supplementary. And then since angle 4 plus angle 5 equals 180 degrees, we go up to our converses. So it says, if two lines are cut by a transversal so that the consecutive interior angles are supplementary, then the lines are parallel. Well, isn't that exactly what happened here? Angle 4 and 5 are supplementary. So therefore, by the consecutive interior angles converse, line J would be parallel to line K. Okay, so that's how we would do a formal proof using these converses. All right, I have another one. So if you want to try this next one, just pause the video and give it a try. So angle 1 and 2 form a linear pair, and then angle 1 and 4 are supplementary. So the first statement, angles 1 and 2 form a linear pair, that was given. Next statement, angle 1 and 2 are supplementary. Well, isn't that the definition of linear pair? So if two angles form a linear pair, that means that the angles are going to be supplementary. So and then angle 1 and 4 are supplementary. That was given to us at the top. And then it says angle 2 and 4 are congruent. So why is angle 2 and 4 congruent? Well, if we go back to statements 1, or statements 2 and statements 3, we have angle 1 is supplementary to 2, and angle 1 is also supplementary to angle 4. So we've learned in the previous chapter that that's the supplements theorem, congruent supplements theorem. It's kind of like almost like the transitive property. But if an angle is supplementary to two different angles, then by the congruent supplements theorem, those angles are congruent to each other. So 2 and 4 were both supplementary to angle 1, making 2 and 4 congruent to each other. All right, so since angle 2 and 4 are congruent, let's go to the picture. 2 and 4 are corresponding angles. So by the corresponding angles converse, that makes line A and B parallel. And that's what we were trying to prove. Okay, so that's how we would do a formal proof using our converses. All right, last thing that we're going to do is we have 4 questions here. We're going to find the value of x so that line A and B are parallel to each other. Okay, so this is just worded a little bit differently. It's basically the same task that we're doing here as we did in the previous section. We are trying to find x so that the lines are parallel. So if we look at the location of these two angles, they're in alternate interior positions. So remember this, if alternate interior angles are congruent, then the lines are parallel. So if we set them equal to each other and figure out what x is, then that value of x would make the lines parallel to each other because the alternate interior angles are equal. So what we're going to do, just like we did in the previous section, set them equal, find x, and then we'll just say which converse makes those lines parallel. So we set up our equation, 10x minus 23 equals 137. And we add 23 to both sides, and we get 10x equals 159, or 160. Then we divide both sides by 10, and we get x is 16. So if x is 16, then those lines are parallel by the alternate interior angles numbers. All right, the next one, look at the location. We have a 74-degree angle and a 9x plus 11. So those are in corresponding positions. So remember, if the corresponding angles are congruent, then the lines would be parallel. So we want to set them equal and figure out what x would be to make those lines parallel to each other. So we're going to say 9x plus 11 equals 74. We're going to subtract 11 from both sides. We would get 9x equals 63. And then divide both sides by 9, and we get x is 7. So if x is 7, then those lines are parallel to each other by the corresponding angles, converse. All right, the next one looks like those two angles that are given are in consecutive interior positions. So remember that if the consecutive interior angles are supplementary, then the lines would be parallel. So we're trying to figure out what x is going to be if the consecutive interior angles are supplementary. So we're going to say 12x minus 29 plus 4x plus 1 equals 180. So if those two angles add up to 180, or in other words, the consecutive interior angles are supplementary, then the lines would be parallel. All right, so the first thing we would do with this equation is combine like terms. When we combine like terms, 12x and 4x becomes 16x. Negative 29 and positive 1 becomes negative 28. And that's equal to 180. And we're going to add 29 to both sides, or 28 to both sides. We get 16x, and then equals 208. And then we're going to do 208 divided by 16, and we get x is 13. So if x is 13, that would make the consecutive interior angles supplementary. So those lines would be parallel by the consecutive interior angles converse. All right, and then the last one, you can try this on your own. But if you look at the location, there are alternate exterior angles. So remember that if the alternate exterior angles are congruent, then the lines are parallel. So we're going to set them equal to each other. 23x plus 1 equals 27x minus 19. Then we're going to figure out what x is to make those lines parallel by the alternate exterior angles converse. So subtract 23x from both sides. We would get 1 equals 4x minus 19. Then we're going to add 19 to both sides, and we get 20 equals 4x. Then divide both sides by 4, and we get x is 5. Okay, so those lines, if x is 5, then those lines would be parallel to each other by the alternate exterior angles converse. All right, so that's the assignment. Attached is the homework. So your job is going to be to complete this homework assignment. If you have any questions, let us know.